Okay, I'm going to go over each question one by one, and then you can refer to it in video if you need to. I don't know how useful these videos are because I think in person you do better. But here's one thing that really helps to understand. All these graphs have an x-axis, and this will dictate what's called the domain. And they all have a y-axis, and this dictates the range. Okay, so one thing to keep in mind is that domain and x-axis generally are called independent variables. And what that is something that ticks on no matter what we do. A good example of this is time. The y-axis is called a dependent variable. And that just means it depends on what x is to determine what y is. And this makes sense when you look at all the equations. It's y is equal to something that happens to x. So in this case, x gets multiplied by 3 times and gets 4 added to it to determine what y is. And generally speaking, when we're looking at a graph, we're always examining the x-axis to determine what y is. So we always read a graph left to right along the x-axis. This is really important in these questions because, for instance, the first question, which says height bracket t or h bracket t, essentially means that the y-axis is going to be the height. And we can't determine it. We can only determine it when we know t, time. So that means the y bracket is going to be in meters in this case. The first question is a diver jumping in the water. And the x bracket is going to be time in seconds. So as we learned in this question earlier, there's some divers standing on a board 3 meters high. And they jump and plummet. And that means we're only concerned with what happens from here, along the x-axis really, to there. And whatever happens here determines this part, the y-axis. And he goes up, or she goes up, and she goes down. Everything that happens under the water afterwards, we don't care about. Anything that happens over here in negative time, we don't care about. Which means the domain is only of concern in there, and the range is only in concern from there. Since we start at 0, let's say she hit the water at 6 seconds. She doesn't, but let's say she does. That means the domain goes from 0 seconds to 6 seconds. If she went up as high as 6 meters, she doesn't. She goes up to like 4 or something. Let's say 4. That means the range is from 0 to 4 meters. And by the way, this is 0 to 6 seconds. Meters for range. So in this case, this is called a limited domain and a limited range, even though the parabola normally goes on forever on the x-axis and is limited only by the vertex all the way down forever on the y-axis. In this case, we're limited by below the water and to the left of time. This is very important. It's the same for financial graphs. So we're going to do a lot of revenue graphs. And revenue is whatever number of items you sold at what price. So this is the basic idea. And later on, they're going to add this, subtracting cost. But for now, they're not going to do it. And it makes sense because let's say you're selling sneakers and you sold 10 sneakers at $100. You're making $1,000. But those sneakers you didn't find on the street, you had to manufacture them. So let's say you had to pay one worker $20 and the materials for the sneakers was $30. And now because there's 10 sneakers, so that's $50 total in cost. And because there's 10 sneakers manufactured, we have to subtract 500. This second line, when we have, this is called profit, it's called revenue minus cost. So these are going to be the two things you have to keep in mind. But for now, they're just telling you this. Revenue is equal to items you sell times the price you sell at them. And all of them will be, if we raise the price a little, we sell less items. And it's all going to come out to a graph. This is always going to be, so that means this y-axis, because this is where the y is going to be in dollars revenue. And you might say, well, what is this item's price? Well, since it's all going to be based on an X value, this X is all going to be the extra item. So number of extra items. Because, for instance, they always start with like, we can sell 100 items at $5. But if I raise it to $1, I lose 10 sales, right? So that's always expressed as this: 100 minus 10x and $5 plus 1x. So all our graph determines is this x. It doesn't determine the final price. We have to add 5 to whatever our x is. And we have to subtract 100 minus 10 times whatever our x is. So this graph of x isn't either of these. It's sort of the extra cost or the extra loss in sales that we then add back to the price or the item sold to figure out. Very important to understand what we're measuring on these graphs. So for instance, in this first question, we have a diver. And as I mentioned already, it's height based on time. So the time starts at 0. And some key questions you'll see when someone dives off the board are these, almost always. What was the height before they jumped? And that's time 0. What was the max height they reached? And at what time? That's the vertex. When did they hit the water? That's the x-intercept that is in positive time. Sometimes you get questions where a dolphin jumps out of the water and into the water, and they want to know, when did they jump out? When did they jump in? And usually that's a sine curve question. And then they'll ask this, domain and range, because they have real restricted domains, positive time, and when they entered the water, and restricted range, 0 to the y value of the vertex. In other words, the max height from 0, the water, to max height. So you can always see the time that they start, or the height that they start, because that's going to be 0 time, and that's going to come out 0, 0. So they started at 3 meters. So on the graph, you would start it off here at 0, 3. Then they're going to reach a maximum height, and they're going to hit the water. First, we're going to complete the square, because the common one is the vertex, right? Maximum height. What height did they reach? So for that, you move the 3 aside. You factor this out. And to factor it out of 6.8, you got to take 6.8 and divide it. Remember that you're dividing by a negative number, though. And you get that. So it ends up being t squared minus minus that t plus 3 over here. And then you got to take the half of that. Helps if you just leave it in your calculator. You get that. And that's the completed square. T minus that squared plus 3. Then you have to subtract the square of that always. So it always just helps to hit multiplication and equals. And you get the square of that. You get all of this. And you have to subtract the square of it. Essentially, it's in brackets trapped in here first. Let me just go to here, let's see. And it's minus because we're subtracting it. And then you got to get it out of the bracket by multiplying by that to get it out. So again, it just helps to leave it in the bracket. Make sure this is negative because we had to make sure it was negative because we're subtracting it. And I'm multiplying by a negative number, and it becomes this. So once I get it out of the bracket, it becomes this plus 3, which becomes this. There you go. So that's the completed square. Oh, and this is plus. So we can tell that the vertex is this. We just say 69, 5.36. And what is that? Well, remember that in this case, you have to determine your x-axis. Our x-axis is always going to be where x normally is, time, seconds. So that means this measures seconds. And remember that this is height based on the time in meters. She started at 3, so she went up as high as 5.36 right here, 5.36, which means my range is from 0 to 5.36 meters. That's my range, which we write like this. And sometimes we write it like this, and the curly brackets means we're including those times as part of the range, those values as part of the range. So right there we have the range, and we would also mark this when we sketch it as a point. X value 0.697 is height, Y value 5.36 meters. And then the next common question they have is when do they hit the water? Well, that's when height is 0. You're going to get 2. You're going to get a fictional one before time here, and this is the one they care about. To figure this out, try to remember that it's all still height. You should always write the height based on t equals to these each time. Like this. And what's the height when they hit the water? It's the x-axis, so the y value is 0. So the first part is we subtract that. It's going to be a negative, and it's going to be, then it's going to be equal to this. And again, it's a negative. And then we're going to divide it by this. Let's see if it's still on our calculator. It is, so we're going to add 3 to it. We're going to divide it by 4.9, negative. Well, it becomes positive, so let's just leave it as positive. We get this. We're going to get the square root, which explains why we have a positive and a negative value, because when you square root something, you get a positive and negative value. So we get the positive version is equal to this. And then there's a negative version over here. The positive version, when we took the square root, is equal to this. And then the negative version is also equal to that. Then we add 0.69 to both sides. So clearly this is going to be the positive one. Then we add 0.69387 or whatever. We get that, 1.73. So that means t is equal to this. And we also get the negative version, which is going to be equal to, add that. It's going to be equal to roughly, it doesn't really matter, 0.7, roughly negative 0.35, something like that. You can always figure that out. Now, remember, that's time, so seconds, which means they hit the water here at 1.74, 0, and in the fictional world over here they also hit the water at negative 0. Something like, this isn't accurate, but 3.5. seconds, comma 0 over here on the left. Now, in the real world, they say, when do they hit the water? Well, you don't include that one. You only include that one. So when do they hit the water? 1.74 seconds. Their height is 0. They hit the water. We don't care below the water. We don't care about negative time. So now we have the domain. The domain starts at 0. Ignore the 0 one. Well, we should tell it, but we explain why we're throwing it out. So that means 0 is smaller or equal to x, which is smaller or equal to 1.739, so whatever your teacher tells you round up to. And we would also write that as curly brackets to include it 0, comma 1.7397, whatever you're rounding up to. And that's called, I think, something notation, function notation. All this is saying is x can exist between these two values. All this is saying is y exists between these two values. Nothing else in the real world graph matters. So looking at the questions and what they're asking, yeah, they sketch, so we would sketch all those points. The height, oh, they're asking a specific time, you just plug 0.6 into this. So occasionally they ask stuff like this. They go, what's the height at 0.6 seconds? And that means wherever I see time, I simply put 0.6 seconds here. So it's going to be 0.6 seconds squared. What was this time? And 6.8 times 0.6. And the 0.6 in squared is going to be multiplied by negative. Square it, it's going to be multiplied by negative 4.9. You get that. I'm going to add 6.8 times 0.6. It equals, and then I'm going to add 3. So they just after the peak at 0.6, they reached this height, 5.318, which tells us since the max height was 5.36 at 0.069, this is on the way up. Sometimes they'll ask you what height do they reach on the way down, and that means you have to figure out what time exists on the other side. Or you can just set the height to equal to the same height as this one and set it equal to your completed square formula. They get tricky sometimes because on the way up, you hit the height there and you hit the height again on the way down. That's true of all your heights before she jumps or after she jumps. There's a height here and there's a height here. The only time there's one height is the vertex. How many x-intercepts? It has 2, but only 1 matters. What's the maximum height? 5.36. When does she reach this height? 0.69 seconds. What's the domain? 0 to 5.37 for the range, and the domain is 0 to whenever they hit the water. I think they hit the water at 1.3 or something. And so that's the first question.